I wasn't sure if it was the same meeting number as before.
Oh yeah, I guess I didn't send out the response tonight or the
Yeah,
Yeah.
there.
I used last
Ho-
week.
Or, yeah,
Homan,
I never changed the number. So,
okay. Homan reminded me, so
okay.
thanks to Homan.
I can.
Oh, no problem.
Okay.
So I'll
Yeah.
I'll
Thank you.
call the list if you want.
Go for it.
Okay, well, welcome to the July 14th, 2020 session of um, Tangerine SDR on Zoom. My name is Dave, KV0S, and this week I've been helping Dave Whitten a little bit with his testing and things. I've been doing some other programming with some and doing lots of Zooms. I've had more Zooms this week than any other week so far. So anyway, we'll go on down the list. Next on the list is Nathaniel in a W2NAF. Go ahead, Nathaniel.
Thanks, Dave. This week I've continued my lots of reading and writing about how the neutral atmosphere can impact the ionosphere and vice versa, which is, of course, all tied in with some of the science we're trying to do here. One of the cool things I did, though, and if people are interested, I could show them later, I did I made a plot of all of the ham radio data that Bill Engelke has been collecting, at least from WhisperNet and RBN, from 2009 up to present, all on a single page. So you can see an entire solar cycle worth of data. So if anyone wants to see that later, I can show you.
Very good. Next on the list is Dan in for XWE, and he's been busy with installing scripts, I think. Go ahead, Dan.
Oh, thank you, Dave. Hello, everyone. Yes, I've been doing some scripts, and it sort of occurred to me that people might wonder why I'm doing this. And the reason is that I'd like to automate the software install for the project. And it was a way for me to learn how to do that. And the scripts have turned out to be pretty good, actually. It has been a little bit of an effort to put them together and kill a few bugs that popped up and figure out the best way to do things. But now I think we have, for some amateur radio software, some pretty good installation scripts. Anyway, back to you, Dave.
Well, fine business. And next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Thanks, Dave. I have what I have been doing. I found a really good ADD converter for my VLF audio board, and it's the Cirrus Logic CS5364. It has 4 audio input channels with a sampling rate of up to let's see here, up to a looks like 192 kilohertz, and no, actually 216 kilohertz. The dynamic range is about 110 dB or so, and this looks like a really good choice. The more that I read the data sheet, the more that I like it. So if I could get all the circuitry to fit on the board as outlined by the size of the leaf module board, then I think I'm going to. That's all I really have. We could talk about some things for the general discussion later.
Yes, and you'd send out a very complete list or email of your specifications. So if people want to check that out, it's on the, I believe, the Tangerine list, and there's quite a bit more detail. Next on the list is Veronica Go ahead, Veronica.
Hello. So this week I met with Dev and he kind of explained to me what the part of the project he's working on and what he's doing with the data and the code that Yuha was showing us with the ionosons. And then I also explained to him what I know about TMUX and VI. And then beyond that, I've just been working on making some more graphs to look at the KP index and the WhisperNet and RBN data.
Very good. Next on the list is Holman. Kim, go ahead, Holman.
Hey, good evening. How are you? So I've been working on data comparison between the data that we received from JennyJump. So 2 weeks ago, my postdoc and I went to JennyJump Observatory to install the magnetometer that Dave Witten provided, and I have compared those data sets just by just plotting those two data sets. So if possible, maybe I can share my data later.
Yes,
So
yes.
that's
Why don't we
all
go
I've been
through?
doing.
We'll go through the list and then we'll come back
Sure.
and this your topic is one of the more pressing ones this week. So
Okay.
we want to discuss this.
Yeah.
So, okay. So next on the list is Bill Engelke. Go ahead.
Thanks, Dave, and good evening to the net. I've been busy here. As you may recall, I've been working on, I figured out how to use my Flex radio as a stand-in for the data engine to try and build out more parts of the local host until we have availability of the data engine. And this week I focused on getting FT8 decoding working, where I can pull it off the air of the Flex radio, decode it, and then display it inside of the local host. You have seen this before. I had a demo of this running all the way back at the Hamcation. However, that was with simulated data, where I was just basically sending recorded data from the simulator over to the local host. Well, now the data is coming off the air. And I found out, and I knew this on some level, that that decimation has to be done right. The Flex radio puts out 48 kilosamples per second, and the decoder software requires 4 kilosamples. And so just to see if it would work, I would just drop 11 samples, and then use one, and then drop 11 samples, and then use one. So that's a poor man's version of decimation, which tends to fold back. It folds back all the high frequency stuff and turns it into noise. So I knew this on some level, but it was very instructive to see it firsthand. So I can copy FT8 signals on the band that are of a strength of 8 or 10 and above. Above that, below that, it gets lost. So the right way to do it, of course, is to apply a low-pass filter before you do that. And I don't want to try and do all that signal processing as just a simulator. It makes much more sense to just wait till we have this running in the data engine, because I'm sure that the FPGA programming for the data engine will be done correctly, where you do the right filtering before the decimation and all that stuff. So anyway, we'll be counting on the guys to do that. And I am planning to develop some use cases, a set of use cases that Scotty and the team can use for developing the FPGA software, at least the stuff that's going to interact with a local host. Now, I can't give any advice on how to do the signal processing itself, because that's not really my specialty, but I will provide a list of use cases such as, here is exactly what we're going to send. Here it is. We already have the process layout, but here's the actual binary stuff I'm going to send down at the code level, and here is what the local host is going to expect back. And so I'll document that. I've got that partially done, so I'm going to try and get that done shortly. It did occur to me when I was thinking about FPGA programming, something for the group to discuss at some point. Is there any telemetry that we need to pull from the data engine? Does the data engine need to be able to tell us anything like what voltage it's getting, or or what temperature it is, or anything like that that would tell the local host what is the health of the data engine? It's just something to wonder about. If anybody has a thought on what we should do on that, whatever the hardware can do, let me know, and we'll include it as a use case. Also, I'm wondering when I can get my hands on a magnetometer, because I'm close to being able to test that. And finally, a note for Dan. Dan, what you said about the scripts is instructive. I am going to look to you for some help developing the scripts to build the local host. It is a very complicated local host. It probably has close to 20 prerequisites, most of which has to be built, and some of them have to be just installed, and it's going to be different depending upon what platform you use. So we're hoping that this thing will run on the Raspberry Pi as well as in the Odroid, but the Odroid uses Ubuntu Mate, and I haven't had a chance to do this yet, but I am planning on taking one or two of the scripts that you developed for installation onto Mate and see if I can install and get a good install in the Odroid. It seems quite feasible, so we'll try that and let you know. So, okay, that's what I had. Back to Net.
Okay, next on the list is Tom McDermott. Go ahead.
Oh, good evening, everyone. I spent a little time this week thinking about how to process a chirp in the FPGA. And I think I put out a white paper this morning. I sent it to Tangerine in the HAMSci list. I got about 5 or 6 comments back on the HAMSci, which are interesting. And Scotty took a look at it over the weekend, and it looks like it's possible this might work. I think I've got a few ways to make it perhaps a little bit more efficient than it is now. But it would put some of the processing algorithms, the high-speed ones that Juha talked about, in the FPGA, so that the output of the Ionoson dechirper would be a low data rate stream that could be readily handled by the host and would have a reasonable amount of bandwidth. So that's pretty much it for this week.
Okay, good. Next on the list, we have Mike, AA8K. Go ahead, Mike.
Oh, thank you, Dave. Greetings to everyone on the conference, and back to you, Dave.
Okay. Next, we have Dave Witten. Go ahead, Dave.
Hello, everyone. I've been working on a magnetometer, well, working with Yeoman and so forth, and doing some other things. And now we have some results. I don't know, Yeoman will have more to say about that, but as far as I can tell, they don't look good so far. But that's it for now.
And next on the list, we have Dave McGraw, N1HAC. Go ahead, David.
Yep, that's David McGaw, no R.
Oh, sorry.
As I tell people, McGaw is Scottish, McGraw is Irish.
Oh, very good. That'll help me remember.
Right. Nothing direct to report, but I've been following the VLF effort, and I just want to point out that 110 dB does not come through a 16-bit data path. I've been wondering if 24-bit data path is going to be available in the Tangerine SDR system. And I'm also noticing that this particular design would just be, extended audio range, would not cover, shall I say, the 100 kilohertz to 2 megahertz, which I think we also want to be able to digitize. But hopefully maybe that's just a redesign of the filters on the main board. So back to Net.
Okay, and then last on the list, we have Dev. Go ahead, Dev.
Hello, good evening, everyone. So I have been busy last week trying to install the ETOS N200 device. at the University of Scranton Loyola Science House building, because I have successfully run the device at my home, in my home computer. But now I'm trying it to move to the Scranton campus, because we already have an antenna, HF receiver antenna installed up there. So as soon as we succeed in installing the device, I think we'll be in the phase of receiving data with the installation. So I think we are at the cusp of some good news.
Okay, well, that brings us to the end of the list. So we're open for general discussions, and I would turn it over to Holman to discuss his results.
Okay, could I have my screen shared with everybody then?
Yeah, you should be able to, Kevin.
Oh, I can. Oh, okay. Okay.
Is that working for you, Human?
I'm trying now. I have some grant access. Okay, I'm just gonna share my desktop then. I have some like access issue. I don't know. But do you guys see my presentation here?
Yes.
Yes.
Okay. So I mean, this is not a really full-blown presentation. I just wanted to acknowledge people who've been really great, helpful, and contributing a lot. So first of all, I'd like to thank Dave Witten for providing the prototype magnetometer, so I can test that at JennyJump observatory site. And Gil Jeffer, one of our engineers at NGIT, actually he was the one who sort of managed the site, and also he provided his place to locate the sensor, because there are some, it wasn't really straightforward to install sort of not so permanent structure there at the observatory. So we decided to use his home to install these magnetometers. But the location, the distance between his home and the observatory is very close. So it's very legitimate to compare the data set from those two magnetometers. And I have installed this magnetometer with my postdoc, Sungjun No. Okay, so it was installed at JennyJump Observatory on June 29. And here I'm going to compare those two data sets. We still don't know whether, but before I get started, even the science magnetometer there has some level of noise, which I guess is because of the civilization nearby, although it's not, it's pretty rural there. But I don't know where the noise is coming from. So that's why I actually use a 10-second moving average, which can decrease the level of noise a little bit. So all the data that I'm displaying over here are 10-second moving average. And the bottom line is that the trend, the magnetic field traces don't seem to match each other. So I think this is something this is outstanding issue right now, something that we need to discuss. So here's a picture of Gil Jeffer and a postdoc installing the magnetometer on top of a big rock. We just decide not to use any permanent structure there because this is going to be temporary, but this is pretty stable. We use lots of heavy rocks around it, so you can, as you can see, things don't really move, and then I guess they are very properly oriented. And the distance, I think this can be a sort of very similar to what we are going to do. If you have a home, have a reasonable backyard, I think this is what you are going to do. The cable that I purchased was what do you call it? The Ethernet cable, 100 feet. But as you can see, there's some slack there, so it's not quite 100 feet full length. So moving on to the next slide, you can see the top plot came from our magnetometer. I actually named it GTJ, 3-letter code, which stands for his name, actually, Gil Jeffer. T must be his middle name. Then Jenny Jump in the bottom. As you can see, I don't really see any similarity, not in terms of the detailed structure, but also in terms of the overall trend. Also, if you look at the actual, this is not the good plot. I'm going to show the next one, the next day, which has same axis range. It goes from 200, minus 200 to 200 nanotesla. By the way, the magnetometer at Jenny Jump is originally manufactured by a NASA scientist called Mario Acuna, who is really, really well known for his magnetometry research. One of his remarkable work, I mean, his design is still used. I bet all of the NASA mission spacecraft uses his design. This magnetometer design is traced back to Voyager project. So even the Voyager 1 and 2 are equipped with his design. And this is his ground-based version of his magnetometer. So I can tell you that this is very, very reliable, very, that has really a good history of successful operations and missions. So as you can see, the noise level is different. Also, the response level is different. But I think the most concerning thing is that they don't really match in terms of responses. So I'm going to show, I mean, these are all different dates. And I realized maybe the sensor is not properly oriented. So I actually decided to plot the total B. As you can see, I don't really see all this detailed structure here, and also overall trend don't match. The other thing to add is that the magnetometer at Jenny Jump, the science magnetometer, is used as variometer instead of magnetometer. I mean, basically they're the same thing, but basically this magnetometer reports only the variation, delta B, instead of reporting the total value. I believe at around New Jersey, the total value should be close to, I guess, 50 nanotesla. But internally, or maybe, I don't know, I have to find out, but either internally or in terms of after they post-process, they remove all the background level, so you can only see the variation only. This is what we typically do. Unless you are really, really interested in a total value, like a geophysicist who really wants to know the long-term variation of geomagnetic field, the total field, we don't really care too much about the total field. We only care about this variation. So that's why we usually get rid of the total background, so you can see the only variation. Whereas the magnetometer, RM3100 magnetometer that Dave Wheaton developed, that magnetometer reports the total magnetic field. So I actually remove the background here, so you can see the variation only. This is nothing more than just B minus mean B. So you just get rid of just bias level. That's it. no fancy technique at all. But still, I don't really see this trend here. So that the traces don't match. And I think the response is a little bit different compared to this. I think the response is a little bit bigger. So maybe this bigger response may have to do with the maybe calibration issue, which we can fix. But I have no explanation regarding this different response. Maybe that has to do with processing, maybe, I don't know. So that's all I have right now. So from now on, it's completely open discussion. Back to Dave.
Anybody have any comments?
So
Yeah,
Hillman, oh, go ahead.
Yeah, I'm wondering if the trace coming from the Jenny jump magnetometer is derivative, not just subtracting out background.
I need to find out. Yeah, but what people usually do is to remove background or mean value, daily mean value. It depends on the group or preference. But I kind of doubt that they actually do take derivative of the data.
Yep, just a thought that might be what you're looking at is the rate of change rather than actual difference from background. Also, what is the cadence that we're ultimately looking to get?
Both
in other words,
of them,
bandwidth.
Yeah, the bandwidth, 1 second sampling, both of them. But here, actually, I took 10-second moving average, so I can get rid of some weird fluctuation of the signal. I just wanted to see the overall trend. That's it.
Right.
So any other comments?
If it were, if the Jenny jump fluxgate were showing derivative, do you think that could that account for any of this?
Well, first of all, I don't think so. Second of all, I highly doubt that they actually take derivative. I think what we usually do is to subtract.
Mm-hmm.
It could be just daily mean value or weekly mean value or IGF model, whatever. So it's simply just subtract.
Yeah.
It's not really derivative. So
Yeah.
I'm not really aware of like anyone who take derivative to report. I mean, people take derivative for their own research, but for raw data report, I don't.
Right.
I kind of doubt that.
Right.
Well, there's a lot of derivative data out there, but it's done with search coils rather than flux gates.
Well, search coil, yeah, that's just completely the output itself is DBDT, so that's already derivative is already taken.
I want to point it.
I'll be just working with Dave Witten to figure out what's going on here. Also, we can use some simple lab-based lab-like gadget to make sure that what we see is actually what's been reported in real time. So that's
Do you know
something
if there's a
we can do.
website that reports the Jenny jump magnetometer?
There is a NJIT website where you can actually grab data, but it's not really being displayed. But you can actually definitely take download ASCII file from our website.
Right. Okay.
I can share the website with you guys later.
Yeah, that would be useful.
Yeah.
I'd like to point out that I wasn't thinking about Raspberry Pis very much when I worked on this. I just made sure the code compiled on it. But it quickly became obvious working with Yeoman that the Raspberry Pi is very poorly suited to this sort of thing because of its lack of any kind of a useful time functionality that comes naturally to it. You really have to have some sort of something, preferably even a simple
Yeah, I mean,
GPS.
yeah, that's something that I forgot to mention. Actually, this when I installed this, I set it up to UT time. So, unless I make some stupid mistake, I think this is UT time. Otherwise, it could be system time, which is maybe network time. That I guess network time is tied to local time then. If I don't do anything.
Network time is NTP. It's universal time and then adjusted. And we use Raspberry Pis for our research, and they trigger on time. So it's as good as any computer.
I don't feel very good about them, but at least without a GPS to at least keep them on track.
Well, do you have NTP running on the Pi to get it synchronized?
I don't know. I didn't set it up, so I can't be sure.
This is just barebone Raspberry Pi system that.
Yeah, well, I think it's in the operating system. You may just not have it set to.
Hyomin, are you familiar with NTP?
Not really. Yeah.
Okay, so NTP is a network time protocol, and so that is a program that will run on the operating system and will sync the Raspberry Pi's clock with the internet time. So as long as that's running and as long as the Raspberry Pi is connected to the internet, you can be pretty certain that the Raspberry Pi has the correct timestamp.
Okay.
So it's certainly to 1 second accuracy will be no problem whatsoever.
Okay.
Yeah, I mean, usually it will give you it will tell you what the estimated error is, and it's typically sub-second.
Mm-hmm.
As long as you don't lose your internet connection anywhere along the way, and you have configured it right. But as a general thing, the lack of I believe it. I don't think there's even any real-time clock circuitry on the board. As a general rule, I much prefer working with the Odroids. They have a battery backed up clock that's standard. They're just simpler, cleaner.
I believe the Raspberry Pi has a battery backup as well.
Oh, you can get them, but it's not a default item. You can have a battery backup. You can have a GPS back and all that. It can be done. It's just it takes more effort.
Yeah, the Odroid doesn't have a battery backup unless you buy one either.
Well, it's just a coin cell that costs $1.50.
Exactly. Yeah.
Yeah, but it's
$4,
very simple.
Yep.
It's not an add-on board.
You can buy an explicit real-time clock to stick on top of a Raspberry Pi if you're concerned about it keeping time when it's not powered up. But
yeah, I mean, NTP is installed by default.
Right. It's just like what you set up in Windows or on a Macintosh to sync off the internet periodically. I don't, being that it's Linux and I don't know Raspberry Pi that well, I don't know where the setting is, but I expect it's in there because we're using it in our research machines.
Yeah, Dave, is there any way for you to put a known field or turn a known field on and off with the magnetometer in it so that you can see what kind of readings that it
Yes,
gives?
I will be able to. They're beginning to let us back into the labs. And I
Okay.
do have a set of Helmholtz coils available.
Yeah, I mean,
Yeah,
that's what I was trying to mention. Actually, that's what we actually skip. That's the process that we skip actually because of the accessibility issue to our lab. Yeah, what we should have done before we actually install it is to generate some kind of known field at a given time, so we know that the magnetometer is responding properly at a certain time that we know. That's the step that we actually skipped. We should have done, but you know, I think now we have access to our lab, so this is something that I should try. So.
That's one aggravation with this all along is I've never had access to anything that give me a sense of what reality should be in order to compare what I get back.
Well, one thing
from
you
this.
can do, barring a Helmholtz coil, is get a reading of what the local magnetic field should be, and direction, and then rotate the magnetometer in various directions. See if you can pick it up at a magnitude that you expect.
Well, that's why there's an option to remote to report total magnetic field and options to look at each of the individual raw and computed values. There's a lot of options in the software. Anyone is welcome to look at the software. It's on GitHub. I keep plugging away at it. I know it's never going to be used in this project, but but I keep working on it because I began it. But I'm not defensive about it. I think it's entirely likely there's egregious errors still lurking. I've gotten an awful lot of help from I really want to thank Julius Maddie. He's been extremely helpful in imparting some rationality on some of these things. But I'm often a little distressed by the lack of communication or means to get feedback from anyone, except, the few people who are immediately concerned, and without any access to laboratory instrumentation. I don't know. I'm blundering around in the dark.
So one thing I'll be doing is to ask Gil Jeffer, who lives there, to sort of like disturb magnetic around it, like with maybe magnet, and at a given time, so we can see if we can see that response at the known time. That way, we can make sure that the magnetometer is responding properly, or whether there's any timing issue there. So, but then that's really a quick and dirty way to make sure. But I'm going to bring it back to my lab and see how we can.
Kelvin, could you scan back through those slides, please?
Sure. What slide are you referring to?
I'm just trying to see if there's a pattern, whether something's inverted or who knows what.
Mm-hmm.
And just to be clear, which is the science magnetometer and which is
bottom one? JJMP. That's our official magnetometer.
Okay, because I've been confused about that too.
So the Tangerine SDR magnetometer is the GTJ?
Yeah, GTJ.
Okay. The Gil Jeffer honorary magnetometer.
me, it looks just on a cursory review, it looks like there's a correlation between X and Z. Like the two
Oh,
of
you
them
mean,
track together a lot.
yeah, blue and red. Yes, that's something that I noticed as well. I actually forgot to mention. Yeah, if you look at this, they go together. And also this happens, I don't know what that is. Big jump.
Yeah, that's a real discontinuity. One thing, Hillman, I would like to ask, in the photo, in the second slide, I guess, the lower one, I assume, and I can't really see, maybe you have a compass there underneath the Cat5 cable. Is that what that is? Or what?
Compass?
Or I don't know. I just see something. Maybe it's something else. I can't.
No, there's nothing
Okay.
around it. I only use a food container here to protect it from rain, whatever.
Sure.
And these are all the rocks.
Okay.
Good. Yeah.
I thought I just in my vision I need to have
yeah, I know what you mean,
appointments.
but yeah, there's no metallic or magnetic stuff around it.
Good.
Is that
but
duct
no,
tape
that's
or?
that's not what that was not my question. Really, I was wondering. I assume that the cable is coming from the south end of the container, that's oriented north-south, and the cable, the direction towards us is south.
I don't know. I haven't really thought about that orientation of the cable itself.
Well, it's not the cable itself, but just to know the orientation of the.
Oh, orientation. Well, so this plate is very much well leveled using the bubble level.
Okay.
And then we rotate the sensor until we see the minimum value of Y with X maximum. So that X is oriented along the horizontal magnetic field line and Y is perpendicular to the horizontal magnetic field line. So ideally Y-axis has to be close to near zero. That's what we did. So we rotate the sensor the horizontal plane until we see a minimum Y.
Okay.
That's sort of standard way of doing orientation of sensor we do usually for other magnetometer setup.
Yeah, I've never had any guidance on that from BNI. The other question, and corollary to that is, I assume that this is equivalent to what the Jenny Jump unit. Certainly, surely it's calibrated in terms of direction. So this should be the equivalent, huh?
Yeah, I mean that's why in the last slide I just showed a total field. I mean,
yeah,
maybe I screw up the orientation, but you know the total field should be similar. But
I'm not questioning that. I just wondered.
Yeah. So, yeah, I have 2 things to do. So then hopefully I can give you some more update.
Okay.
It's been a little bit frustrating because of the fact that, you know, we're not allowed to use our labs and stuff. So, but I think now it's okay. So I'm going to try.
Yeah. We're hopeful that someone may actually have a magnetometer set up here late in the summer or sometime, but we don't really know when, and it's not ours. It's somebody else's, but still it would be a sanity check.
Is that Dolores Knips?
Yes. So her plan was to install in May, and the COVID got in the way of that.
Yeah.
They still plan to install. This is on a research experiment farm for the university, in conjunction with an existing weather station or some near proximity so they can share the networking. And I talked to the atmospheric science professor here, and he said hopefully August is his next. But you know, somebody has to come from Boulder, Colorado, to install it.
Right. Who's your atmospheric science professor there?
Patrick Market.
Okay, I don't know him.
He studies. One of his big things is snow thunder.
Oh, okay. Cool. I think that's considered a form of severe weather.
Yes.
Yeah. Yeah.
Who's were you saying is into snow weather?
Patrick Market, atmospheric scientist at our university here.
Mm-hmm.
So atmospheric science professors are in the same department as I am. So forestry and atmospheric science get lumped together. We're School of Natural Resources.
Mm-hmm. And sorry, did I hear you say snow lightning or just?
Well, it's lightning thunder during
Right.
snowstorms.
Yeah, I'm wondering if he's the one who gave a talk to us at Dartmouth on that. And I actually had some exceptions to what he was saying.
Okay. Well,
is he a grapple guy? Do you know?
I don't know that, but I do know he was trained at University of St. Louis University.
I'll have to look back on that. Yeah, the person who was talking to us was saying that snowstorm, thunderstorms, lightning are caused by grapple, and we're saying every storm I've been in that's had lightning, it's been powder snow.
Yeah.
It's an
he
interesting
has
topic.
had NOAA grants on this topic.
Mm-hmm.
Gelman, you may wish to unshare your screen.
Okay. Yep. I just did.
Okay.
It's interesting to note that on the science magnetometer, the red trace is the one that's nearly constant over the day, whereas on Dave's it's the other colored trace. So it's like there's perhaps an orientation issue. And secondly, I noticed that on Dave's there's a large response uptick in the hottest part of the day, and I'm wondering if there might be some temperature sensitivity. Homan, did you record the temperature along with the measured data?
Well, I mean that's embedded with the software that he provided. So we do have sensor data, right? Actually, I had a question for Dave. There's like R temp and L temp. I don't know what those are. There are two temperature recordings.
Yeah, well, by default, it should report both the local temperature, the near on the near board, and the remote temperature, the temperature sensor that is.
Oh, local and remote.
There's a sensor on each of the two boards that are connected, and L is local and R is remote. In some cases, when you're working with a single board or doing other things, you want to use just one or the other because you get errors if you try to read them both. Things like that, but they should be there if you need more accuracy. I think I put about all the significant digits that were meaningful, but it should be by default a normal part of your log file.
Mm-hmm. Okay.
Might be worth looking at differences between the two if there's a big discontinuity or peculiar, something peculiar.
Okay.
I confer with that because I've been running the software with one of the simple boards almost as long as Homan's been, maybe even a little longer than Homan's been using his board.
I finally have let's see. I don't know whether I finally have a cable that will let me run outside into my yard. I'm actually in the city, so I'm sure I'm at a noisy location, but I should be able to put a pair of these out in the woods at the edge of my yard, a remote one, and but at the moment I've done something awful to one of the ones I've been testing, so I'm building up some spare boards I had.
Okay, so right now you're recording the temperature, but you're not using that information to compensate the measurements?
I'm not using it in any of the software. No,
Okay.
it is logged, so it's there, and someone can do with it. I had no real good idea what to do with it, but I put it there for whomever.
Yeah, it'd be interesting to see it overlaid on the graphs, to either, to let us know if temperature is an important or not an important factor at the scale that you're measuring.
I'm sure we can prepare some graphs that show that.
It seems like the red and the blue traces have they all have a fairly large, almost entire day dip in them. This is a very long time scale type of curve going through that, looking at the presentation Yeoman sent out earlier. So it starts off higher around like 0 UT and then dips down to a minimum somewhere between like 9 and 12 UT, and then it goes back up. So yeah, maybe that's a temperature.
That was my guess. It sort of has that appearance. I don't know how wide the temperature swings were that day.
The little I can tell from looking at the data, my only reaction is it looks a bit like what I've seen working with them when I have the orientation different than I was expecting it.
Did they say anything about temperature response?
Did the manufacturer say anything about it?
Right.
They say they're temperature compensated. The devices are temperature compensated, but they do not detail what that means. Okay. There's no specs on that, so we put a temperature sensor on each end, just for good measure. They weren't expensive.
It is funny that the X and the Z coordinates or components are so well correlated.
That isn't, yeah, I noticed that, and that is not something that I would expect.
Yeah, you certainly don't see it in the regular Jenny Jump flux gate, the science grade one.
Always working with this, I have been nervous in the code. I made some early mistakes. Working from the example code that was provided that wouldn't compile on any of the devices we're using. I worked from their examples. I used their method of grabbing several I2C registers in a row, which each one of which contains one component vector of the data, X, Y, and Z, and you just ask for the whole group. I've never been utterly convinced that I was treating them correctly, but it's as nearly it's as nearly rational as I've been able to determine.
What do we have some sort of idea? Like, so Dave Whitten, if you were to guess at what might be going wrong, where would you look first?
Number one is I'd look at the orientation of the device. Perhaps rolled 90 degrees or something. If X and Y, for instance, were swapped. I haven't really had time to completely think about it. I was doing some other things today, but that's where I would go first. But I wouldn't point any fingers. That could easily be in my code somewhere.
Yeah, the problem is most ham shacks aren't equipped with a constant switchable magnetic field generator, which is kind of the piece of test equipment you need to work on this problem.
I've been thinking about it.
They're not very popular items at the ham fests either, are they?
Yeah. Now you will notice that 2 of the sensors are about 3 millimeters long, and 1 is about half that. And I assume the one that's half of it is a Z. Is that right, Dave?
The Z, they're really all the same, I believe, but the Z one is standing on end compared to the other 2.
Oh, okay.
That's how it is. It's physically a little different, but it's just standing up on end.
So that makes it pretty easy to be sure that you have the Z one in, well, either the right side up or the upside down position, but you're probably not going to confuse the Z with a horizontal component.
Probably not, but the whole thing is a unit, so it's if it's wrong, it's just wrong, I guess.
Yeah. It's been a long day here. I would think that if the Z were that as long as you get the Z correct, if the X and the Y are rotated around, the Z should still be correct. It should either be the correct, or it should be opposite of the correct, which would be just multiplied by -1 and you get the right answer. But I don't think I see any of these traces matching.
Not completely.
And it's also very, like Hyomin showed the total field, that you would think the total field would match.
Hyomin, did you use my calculation of the total field, or did you do it separately from the raw values or something?
I just did by myself in Python, like x squared plus y squared plus z squared.
It's probably the wise thing. Yeah.
When you're you're talking about like the errors in your code, like how much coding is it to get these numbers? So you have to do a conversion between a voltage that you get and the nanotesla value.
There's only a simple multiplier between that corrects for the gain.
Mm-hmm.
It's a digital value that's returned, not an analog one.
Okay, so really you should just be pulling off actual magnetic field values, and you're just scaling them, right?
You'd think, yeah. That's what I should be doing. I'm just not always. There was a point where I don't remember what it was. There was a command that in some situations could overwrite like the X value. There was a command I was issuing that was causing the X value to be way out of whack, and Y and Z I think were more sane. Julius helped me sort that out. He was debugging it at the I2C level, mm-hmm. I believe, and just watching I2C things and decoding them. Whereas I'm doing it, I've just got C code, and it's. I mean, I believe it's right, but I don't trust anything.
But if it's funny because like if you're just pulling off a digital value and multiplying it by a scaling amplitude, like you'd expect the curve shapes to be the same between the two. Like there's not a lot to not a lot of places you can screw that up in the code.
I think.
Yeah.
Yeah, unless you get the endian wrong.
So,
Or something like that.
Dave, have you heard anything from Jules lately?
Yep. I've been going back and forth with him today about some other things. He's looked at all kinds of subtle things like putting in little delays at different points after issuing commands and trying to quiet the I2C bus to be sure there's nothing. I mean, he's looking at it at a pretty subtle level, and with a much better backgrounds at debugging or evaluating things in difficult circumstances than I'll ever have.
And if it's just a time stamping issue, then wouldn't it be like, you shift it left or right a little bit, or maybe you see some deformation of the signals, but we're seeing,
yeah,
they look completely different.
Yeah. I'm a little bothered by that discontinuity in the one graph. I'm not sure what would cause that, except something stalling the whole process. And I don't know what would do that. I haven't seen that ever happen.
Right there.
Yeah.
Could it be a loss of a couple packets?
Well, it's not writing across the network. It's actually writing to, in the case of a Raspberry Pi, to the SD card for the log files.
Well, so Kyoman, you have a set of Helmholtz coils that you should be able to.
Not at this moment, but I think I can just make a simple solenoid to generate a known field.
Yeah.
I mean, Helmholtz coil might be much better. Maybe we can purchase one, but as you know, all the budget spending is frozen right now. We're not supposed to spend any money. Non-personnel related expenses is sort of almost banned.
Yeah.
We can just make a simple solenoid to generate a known field and see what happens.
I also have to. My father was a geologist, and are we sure that the stone has no magnetic field of its own?
Well, I guess it depends on type of rocks, I think, right? So.
It looks like a glacial erratic, but I can't really tell.
Is it a glacial erratic that got pushed down from
Well, that's what it looks like in my experience, but
up around the pole.
Yeah.
I don't know. Just kidding. But it looks like a good piece of New England or East Coast woods rock to me, but
yes. But if that had some magnetic fields inside the stone, that could be affecting our ability to measure.
That I really doubt that, because we're not really talking about sensitive measurement, I think.
Yeah.
Yeah. I wish we could measure something like that.
Yeah, definitely one of these where you need a switchable field in one axis. There could be a software issue that gets half of one register and half of some different register, all kinds of things. That you need a good lab environment to really test these kind of things out.
My research experience, I have used a lot of these ranging lasers with electronic compass in it, and I know with those instruments, the compass, a three-field compass, is the most fussy of all the instruments, and it required daily calibration to have anywhere near accurate numbers.
I have no idea about the baseline, if there's baseline and baseline drift of any sort with this sensor either. Presumably they've corrected that out, but that's a presumption.
Yeah, the tight correlation between X and Z really concerns me, because that you wouldn't expect to see that in the real world, would you? I mean, in fact, you should be able to rotate the thing and see those things reverse or something. I mean, if it really is measuring the Earth's magnetic field.
Well, if you did have the orientation wrong, is there some orientation where the two components, even though they're orthogonal, would be relatively tightly correlated?
One thing I'll mention, it might just be a time scale problem. If I can draw in here, if you look at this part, and you look at all of this, those may actually correlate, except for the fact that these two are going together. But if you look at that one and the blue one down here, they track. And if you look at the green one, it tends to track what the red one is down below. Coincidence maybe, but that's what my eye is seeing.
Let's look at another one. Let's see.
Yeah, it could be a scale and offset problem still.
If you look at
This red and this red have a correlation in the middle.
and if you look at where they cross over on the colors, there appears to be like about a 4-hour difference between the curves.
Yeah.
Did you say 4 hours?
Yeah, it looks like there's a 4-hour difference offset between the two curves.
Now, it could still be finding patterns in noise, but
Yes.
Yeah, humans are good at that.
Human, out of curiosity, how certain are we sure that the Jenny Jump science grade magnetometer is really calibrated and doing what it's supposed to be doing?
You mean the science one?
Yeah.
I don't know. I mean, that's what I could do is to compare this to some other magnetometer that is reported to SuperMag website. You know,
Yeah.
SuperMag. I don't know which one would be the closest one. Maybe the one in Virginia. I don't know. We can compare this to one of those what is it, the oh my god, yeah, USGS magnetometer.
Yeah.
What about either Dave or Haystack? Dartmouth or Haystack? Do they have magnetometers?
I don't think we have one currently up here at Dartmouth.
Probably Haystack, maybe. I can take a look at those pretty easily. I mean, you know, even though they are a couple of hundred miles away apart, I think you can still see some similar pattern. I mean,
okay.
Not the detailed pattern, but maybe the overall pattern should be similar.
Dave McGaw.
Oh, sorry.
Yeah, Dave McGaw, you have Helmholtz coils, right?
Yes, I just haven't been able to make use of them, and I need to get the test magnetometer running.
But so Dave Witten already sent you a test magnetometer?
Yes, I do have one. I just
Okay.
haven't had time to
Yeah.
get it running.
Okay. Well, if you're able to do that, I mean, thank you very much.
That would help a lot, yes.
Yeah,
Yes.
that would be a great help. Thank you.
And if you need additional parts, let me know. I have restocked since
Oh, very good.
I was running out at the time I sent you those things, and things were getting kind of crazy.
Well, I've got parts at the lab too. I need some. The critical chips were there.
Yeah. Well, the real little chip keeps ending up jumping in bizarre directions.
And Hyomin, do you only have one of these sets?
Yes.
Okay.
Set.
Because I'm curious if you set two of them up side by side, if you would get the same result.
That would be nice, yeah.
So, Dave, would you mention who has sets?
Okay, at this point, I sent Dave McGaw and John Gibbons each kits, which they may or may not have had a chance to assemble. I have sent Julius a pretty bare kit, but he seems to have been able to get it all together, and he's been done a lot with it. But he had a deer fence that was zapping things every so often, that was giving him difficulties. I think he said he managed to cancel it out somehow. I don't know, but he's pretty sharp guy. And then let's see, and Hillman has one set, and I've been building a set for Dave Larson here, so he can duplicate things for me. And I might have one more set that gets finished soon, maybe, if I don't destroy any more of the boards or do any more awful things.
One thing I'll also mention that I have is a science grade Bartington flux gate that's actually analog, so difficult to screw up. It's something we had flown on our during our balloon program.
Can you do just simple comparisons with?
Yes,
with
that's
this?
what I'm saying. Is I can use that as a sanity check.
Yeah, that would be wonderful. Sanity's thin on the ground sometimes around here.
So I'll try to get to that shortly. I've had a number of other projects along the way.
Actually, I also have a Bartington magnetometer, so maybe I can do some more sanity check.
Yeah, I think that's a really good idea. Because, yeah, I don't know if anyone has really used the Jenny Jump magnetometer recently.
I haven't been able to find the data on it. I find reference to it on a number of people's web pages, including Andy Gerard, but I haven't found the data.
Holman, did you do these graphs in MATLAB?
Python.
Just.
Yeah. You didn't use IDL?
No, I have already converted.
Oh my gosh. Unbelievable.
Well, I still use IDL, but for something simple, I use Python. Yeah, my majority of magnetometer processing algorithm, I still have lots of IDL code, but I try to use Python as much as I can. It's a lot easier to work with others, like especially like with students who don't have good access to
IDL licenses.
Yeah.
Yeah. Hmm. It is curious if this chip is supposed to be, you just pull the measurement right off the chip in a digital form, and you're not supposed to really do any monkeying around with it besides multiply it by something. And this is what we're seeing.
Another thing I'll mention that I have that I can hook up very quickly is, let's see, it'll do I squared C. I've been using it for SPI, but I realize it does I squared C. It's a USB interface that allows me to just clock these types of chips and test them. I can hook that up to the magnetometer and make sure that we know how to read it properly.
Oh, one thing, well, a couple of things that I didn't mention here is that, so as I said, this is like 10-second average, moving average. But when I look at the raw data from the RM magnetometer, I see lots of like up and down, up and down. I don't know whether that's actually, we can call it noise, but it seems like a really like lots of like, step function like fluctuation. I don't know where that comes from. Is it really a noise around it, or is it really maybe a processing issue? But that was removed because of this 10-second average.
Now, the magnetometer, this PNI magnetometer, you have the ability to set it to run in different modes. Is that correct?
That's true.
Okay. So which mode do you have it set to run in right now?
Well, in which sense? There's what
knobs can you turn?
Okay. Most of them, I haven't absolutely implemented everything, but where they have given me a register, I have usually made an option to put something in it. There's a gain setting. There's a number of there's a samples. What do they call it? A CCM register. Oh no, that's something else. The number of times it takes multiple samples, or it reads the sensors multiple times per sample that's reported back. And that can, by default, that's the default readings that he's using here is I think 75, or at least that yields an effective gain setting of 75. That is what I have to divide by in the code. At different sampling options give yield different gains, and there's options to change those. There's options. Let me think. Well, the one I was working on today, and I sent out a note to everyone that was using the code that I knew of, that I had fixed something, and it turns out I hadn't done it quite the way Julius meant. But there's delay. There's a couple of different kinds of delays. There's the number of samples, whether you sample 1 time per second, or what the delay in the sampling loop is, or overall loop. There's a whole page of options basically that have not all been exhaustively tested by me, but at least I think they're rational. Some of them may be useless, but I think I don't have it right in front of me, but it's on it. I think it's on the GitHub page. You can look at it there. If you get, it's not in HamSci, it's in WittenD, GitHub WittenD.
I have a question to it, and just let me know if this is totally naive. Do we have any contact partner at the engineering department of the company that makes this sensor? to talk to and
We, ye- yes, yes, we do. At least mostly by email. But both I and Julius have contacted them at different times. He's actually, I think, gotten to one of the guys who made the thing, and got various different kinds of gotten interesting information. One piece of which is that he thought one guy thought our project was really interesting, that we were on kind of pushing the edge of what this, we were definitely pushing the edge of what this could do at its very best, that there may be variability between the devices, and that they knew how to make even better ones, but that made them very expensive. And he didn't say how they did that, how they could do that, but he said they knew more. They knew how to make stuff that we don't have. But so yes, we have we have contacts.
Okay, so he didn't say anything about some requirement to immerse this thing in liquid helium or something. It's not, we're not missing something fundamental.
No, nothing like that at all. Nothing like that. Though I have considered going and buying some nitrogen just to see what happens. It's cheap, and I've got a carboy.
Okay, I'm going to need to leave the meeting at this time. Thanks, Dave, and thanks, Holman. This is very good data.
Thank you, Tom.
Thank you, Tom.
Good night, Tom.
I really value everybody's input.
73.
And a warning to Dave in particular, anyone else who's using this code. I bumped it to 0.0.8 today, but it will probably go to 0.0.9 tomorrow, because the -U option, I implemented it wrong. It doesn't do anything useful at the moment, but I'll fix it. I've already fixed it in the code, but I haven't pushed it to GitHub.
So noted.
Okay.
So this,
Okay.
yeah, okay.
These are the knobs that I've making sense of them. You know, some of them are just presentation. Some of them probably that NOS register -A. They basically told us to leave it alone, but and it will probably disappear.
I like it. You don't use unless you know what you're doing.
Yeah.
That's always, that means it's the first thing you're supposed to twiddle, right?
I know.
I know if Andy Gerard were on this call, that's the first thing he would try to adjust.
Okay, what does this do? They give us enough rope.
That will get commented out of the code very soon. But Jules really wanted to play with it.
Yeah.
Yeah. I can imagine David would want to try that too.
You can try. It doesn't seem to hurt anything, but it actually applies to an earlier revision of the ASIC, I think, and it may still do something, but its function is subsumed in some other commands. Probably the cycle counts, this -c cycle counts, default 200, is probably the most interesting one for most uses. And I think early on when we were looking at this, Tom, who unfortunately just left, had thought it might well be useful. Looking at the specs, he thought that would be an interesting one to play with, as I understood his comment. This is the default. Hillman's been using the default. That yields a gain of 75. which is what I divide the raw values by. I believe the raw values come back as signed, I believe as signed integers, and I divide by the gain, which I don't think is separately settable. It didn't make any sense to change that. This TMRC register might be.
Now, does this count? Is this also what sets the? Is this purely gain, or is this also what sets the resolution, like the nanotesla resolution?
It could well. It does affect the nanotesla resolution, and that's probably why we may want to go higher with it or something.
And so
there's actually there's an option somewhere, I don't know where it is, that actually shows you the little table of how they relate to each other. All it does is shows this little table and exits. I don't know where it is, but should be in there somewhere.
Now the magnetometer sample rate, that's somehow related to the count too, right?
Yeah, they're interconnected, and I wouldn't. Yeah, they probably shouldn't both. In the end, they probably shouldn't be both accessible. But it was something I was. It was involved in my early difficulties to read back the values correctly.
Yeah, because like you can't, the count, the number of cycles that it counts is going to take up a certain amount of time, right? Like 200 counts is going to take a certain amount of time to do. And if you you can't set your magnetometer sample rate to be shorter than the amount of time that it takes to get through a cycle, right?
Yeah. Yep. And what it does, I believe, as I recall, the documentation, if that is set to a insane value, it I think the TMRC value wins. It won't let you set. One of the other of them wins.
Okay. If you set the count higher, does the curve become smoother?
I don't know.
Like if you, because isn't the count, is that sort of like averaging?
Essentially, it's averaging. I think in the default case, it's averaging 200 reads per axis per sample.
So like if you set that to 1,000, you'd hope that some of the variability that we were seeing would go away.
Maybe.
Maybe.
Yeah. And that is discussed in the documentation. That dash capital E is what shows the simple little table that is really a direct crib from the documentation that kind of shows the relationship of the three values above it, I believe, or the the dash D crept in there. It's just the polling loop, but that's how fast the whole program just reads in a loop. And there's a timer in it too or something. And the whole thing's not interrupt driven. It's very simple, but it was, I had to have something to read the sensor with. And now the only other thing I have that could be useful, and frankly, I haven't done much with it, is I do have one of their demo boards that they sell for more money that supposedly works right, and some software that goes with it. Unfortunately, it's Windows software, so it's kind of a hassle for me to test. But I can do that. I'm having difficulty getting up and down my stairs and carrying things around. So, and my only Windows machine is upstairs somewhere.
Hmm.
But maybe I can do something.
It'd be interesting to put your demo board and the board you made side by side and see if they track each other.
That's always been the intention.
Yeah.
You know, I just wanted something, but and I gave one to other folks.
Yeah.
And so I had to get another one. And,
how much were the demo boards?
a couple $100 piece.
Yeah. Hmm.
But they're, you know, but a lot of the things, you know, this is designed to read either a single nearby, well, you could probably read near or far. And I believe you can put in other bus numbers. I haven't really gotten Scotty's thing clearly, but it should be possible to adjust to what he was doing by using the, I don't know, the dash B and probably some other parameters that are in here. So there may be some that are just commented out of the help.
Mm-hmm. Hmm.
You can read just the magnetometer and neither of the temperature sensors. There's stuff to set up the log file paths, and I intended, don't know if I implemented it. Well, there's a option to set particularly the path and the prefix for the log files with the intent that, like as Yeoman's done, the -S, capital S, is a prefix for the log files. The output file path, yeah. That's, you know, for a ham, it's good to just prefix the thing with your call sign. And that way all the log files will have that. They roll over every evening at 00 UTC. Now, the question has been asked a couple times. What I'm doing in the code is I'm using the system time, but I'm reading it in the UTC. There's a process for getting UTC time from the processor, and I'm using that to roll over the logs and to timestamp the logs. There's two options. There's a raw Unix time option for that too. There's a thing to have it display the total field. Why is there a small t in it? I don't know. But yeah, there's a total field. There's a just the usual things. Yeah, that's the -E. That shows the relation. If you'll notice, 200 cycle count gives you a 75 gain. And that's, I believe I select that in the, I actually looked this up in the code.
Mm-hmm. Yeah, I remember seeing a table like this before in the manual.
Yeah, it's actually from, I've got the reference to it there. And then there's an option just to see what your -P shows you, what all the parameters, what it thinks, you know, it got from all the parameters. My cat's getting impatient.
Well, Dave, this is Bill. Just to throw it out there in case you're interested, if you want another set of eyes on this, I could take a look at it. I've got a pretty quiet environment here. I have all the lab equipment, not well, all the computers, all the different computers necessary to test it.
Okay. Well, I'll see what I can do. The prototype boards make me, are quite a bit of effort to build, and I've just about run out of the blank, the blank ones. One other option I was going to mention is that there's an option in there somewhere for to output either comma delimited or JSON output, and the default is I don't know.
The default is not comma delimited; it's space delimited, and -J does a nice JSON packet, but it's curly bracket delimited, not square bracket delimited.
Yeah,
so it's not an array. It's a whole series of JSON
tuples.
packets. Yeah.
Tuples. Yeah. Well, you could do it either way, but usually, my experience writing things to consume JSON from something like this has been that they sometimes go crazy if I put the square brackets around things, around the whole works. And
my code
I wanted readable code.
Yeah, my code was reverse. It went crazy with the curly brackets.
Huh. Well, I'm sure there's.
But that was the Go parser.
Well, this is not intended to be to output a JSON file. It's intended to output JSON strings, which are tuples in this case. Anyway, there'll be a fresh thing as soon as I get a response from Julius on the change I've made.
I'm going to have to head out, so I'm going to say 73 to everybody.
Well, thank you all.
73 Dave.
Thank you very much, everybody.
I think I'll leave as well. 73.
73.
See you tomorrow, Nathaniel.
Yes, Dev. I'll see you tomorrow. I'll try to get there around 9.
Thank you so much.
Okay.
73.
73, everybody.
Bye-bye.
Okay, 73.
73.